Welcome, friends, to the series of learning containers and Kubernetes. So, in the previous lectures, we have created the GKE cluster in Google Cloud Platform. Also, we have created number of Kubernetes clusters in different environments like on-premises systems, like AWS EKS environment. Also, we have created managed container services like Google Cloud Run or ECS Fargate. So now we are going to monitor those Kubernetes clusters. Doesn't matter where your cluster is actually, doesn't matter whether it's on cloud platform or whether it is on premises system, but we are going to have some open source monitoring tool installed on the GKE cluster so that we can monitor our clusters in different ways, like how our nodes are behaving, how our pods are behaving, how the different deployments are behaving, what are the CPU consumptions on node level or the CPU consumptions on pod level. So macro level or micro level, we can monitor the clusters, GKE clusters or Kubernetes clusters or AKS clusters or EKS clusters. So we can uh, monitor any kind of Kubernetes clusters using these Prometheus and Grafana. So Prometheus is the tool through which we can actually monitor the Kubernetes and its components. So in this particular lecture, we will try to install the Prometheus, and the Prometheus will actually extract or generate logs on the clusters, and the Grafana is the other visualization tool which can be integrated with this Prometheus so that we can graphically using different dashboards to visualize our environments. So in this particular lecture, we will install the Prometheus, and the subsequent lecture we will install Grafana and we will integrate both of them and create fantastic dashboards. So let's stick together to have these fantabulous demos. So friends, this is our Prometheus architecture. So we need to little bit understand what goes beyond the screen. So if you can see this Prometheus server, we are having three components over there. One is TSDB, so that is a database where our metrics logs are there recorded. And we are having a metrics retrieval process that actually retrieve the metrics from different environments. So we then, the Prometheus servers then use this TSDB, the database, where actually it stores the matrices after retrieval from different environments. So we can see that we can get the discovery targets on Kubernetes and console or file SD. So these are all service discovery from where from these targets, Prometheus actually collect the metrics, and as well as it is having the node exporters, and uh, it is having the slash metrics. So these apps having these metrics have these tags with slash metrics, collects the data, collects the metrics from these apps through these metrics process. So once this TSDB got these data, we are having this HTTP server through which we can actually access the Prometheus from browser. So there we can interact with these TSDB, and we can visualize these things through these Prometheus web environment. Now we have the push alerts. So there is an alert manager where these alerts are pushed. So basically, whenever there is some problem happens, if some metrics is made the target, then probably at that moment you have just set up the alerts through this alert manager, and at that time these alerts will be pushed to this alert manager, and the alerting service will then be subscribed with Slack or email or X Matters, etc., etc. So the alert manager is something which can actually deliver the alerts to different channels, and this alert manager is being triggered through these push alert triggers from this Prometheus server. There is a PromQL, which is basically the query language, which actually helps to query different matrices, and it can be pushed to Grafana, or we can use the Prometheus web UI and the different API services as well, through which we can interact with these Prometheus servers through PromQL. So this is the query language which actually used in the Prometheus web UI or Grafana or different Prometheus APIs to retrieve the logs or retrieve the metrics data, either showcase to some visualized dashboard or some logs or through some programmatic way. And as well as there is a push gateway through which the batch workload is being can send the data to Prometheus servers as well. So this is the overall architecture of Prometheus. So the main thing is at the central, where we are having these Prometheus servers, having this TSDB component, which is the database holding all the matrices. And this matrix retrieval process sends the data to TSDB after receiving the data from different targets and different exporters. So after then, this database can be queried through PromQL, or it can send the data through some push alert mechanism. And through this alert manager, we can send the alert logs to different channels or through some ticketing tool. All right. So this is our overall Prometheus architecture. Now let's move on how we can install this Prometheus and how we can use these Prometheus to capture the different matrices. So let's go to the console. All right, friends. So this is our Google Cloud Web Console, and we're in the Kubernetes cluster dashboard. So right now we are having one cluster. So that is my GKE cluster. And if we can see, this GKE cluster is located as US Central 1C. Let us go to this cluster and let's see what are there. So we are having a zonal cluster, and this zonal cluster is actually located at US Central 1C as the control plane zone, and it is having the default node zone distributed in US Central 1 A, B, C zones. So all these zones are on US Central 1. Okay, and we are having only three nodes right now, and it is having these automatic pod auto scaling, and also we are having node auto provisioning. So that's why, I mean, whenever there is a demand of more pod to be created, it can automatically allocate those pods to the auto scaling feature, as well as if the pod needs more resources, it can vertically scale that pod as well. And whenever more pods are required and we do not have the capability in the nodes where we can provision the pods, it is having the node auto provisioning, so that the node will be added in the node pool as well. And this is how it can grow. So anyway, we are not going deep into this. So this cluster was created in the earlier lecture, and we are highly recommending you to see the lecture where we have created these node pool cluster, GKE cluster, and everything in a detailed way. We went through a long video where we have covered all the details, all the micro level details, what are there to create Kubernetes cluster in GKE platform. So please watch that video, and we are highly recommending you to watch the video so that you can have the detailed concept on GKE. Now, our main aim in this particular video is not GKE. Now we are going to install the Prometheus on this GKE environment, but the way it is going to be created is exactly same in any environment. So even you are having the on-premises systems where the Kubernetes is installed, you can use the same way to install the Prometheus on your Kubernetes platform. So basically, what we will do, we will actually connect to this GKE cluster, and there we are going to install the Prometheus. So basically, it doesn't matter where your cluster is hosted. Basically, the main aim of creating the Prometheus server will remain same. So for now, we're going to connect this GKE cluster. So I'm just going to grab this command to connect to this particular cluster. So I'm just connected in the Cloud Shell. So let me paste the gcloud container cluster command to connect to this cluster endpoint. So, okay, we have connected to the cluster. Let's see what are there in the cluster. So basically, we did not do anything. So let's see get all. We don't have anything other than the default Kubernetes services. So practically, our Kubernetes cluster is having no load right now. No workload is there. All right. So now let's do something to create the Prometheus server. So let's go to Google and let's use this search in the Google search engine, which is Helm, Prometheus, GitHub. So basically, there are a number of ways you can create your Prometheus. So one of the easiest way is to do it through Helm chart. So Helm basically a repository, and it is best suited for the Kubernetes. So whenever there is some packages needs to be installed, Helm is the best way to install through Kubernetes. We are having the Helm community, and through this Helm community, they are building different kind of things so that it can be installed in Kubernetes in a very easy way. So similarly, the Prometheus is also can be installed. This Prometheus can also be installed through Helm charts. So this Prometheus community build this Helm chart, and the very first link goes to this GitHub repository for this Helm chart, where it is actually going to install the Prometheus. Now, if you go to these charts, you will see different elements can be installed through Helm charts. So we are interested with Prometheus. So just look for Prometheus, and there, if you go inside the Prometheus, you can see the details how we can install this repository in our Kubernetes environment. So exactly what we will do, we will just copy this thing, and we are going to run this in our cluster. So it is going to add the Prometheus community repository, which is a Helm chart. This is the GitHub repository page, what exactly we're going to add right now. Now, once it is done, we are going to update our repository, and it will install the repository. It will successfully got updated. So now we are going to install this Prometheus. So I'm just going to use the name. I mean, there is no need to give some other names. I mean, you can definitely give other names, but I mean, for sake of simplicity, I'm just going to give the name as Prometheus. And then you can give this Prometheus community / Prometheus so that it will start installing this Prometheus in the environment. So it will take some time. And once it is done, the Prometheus will be installed on the Kubernetes cluster. All right, friends. So after a minute or so, the Prometheus got installed, and you can see the namespace it has chosen as default. Maybe we could probably give a good namespace, but still, I mean, it's fine. We're absolutely fine because it's just a demo. So the default namespace, and it is saying that it has deployed revision 1, and it has also given the commands how we can actually expose these ports. But actually, this is saying that we can export the port. So I don't think that this is a good way to expose the port, because port can die. It's better to go with the services. So first and foremost thing we can check, like what are there created under the hood. So if we say kubectl get all, we can see couple of things has been created for this Prometheus. So let's see one by one. So we can see that it created couple of pods, okay, and it created couple of services as well. So first go with services. So you can see this Kubernetes service was already there as it was default one. But from here, Prometheus Prometheus Alert Manager headless, Prometheus queues, state metrics, Prometheus node exporter, Prometheus push gateway, and Prometheus server got created. So these services are created, and you can see corresponding pods also running. So for example, if you say node exporter, there are two pods are running, three pods are running actually. For Prometheus push gateway, we are having one. For Prometheus server, we are also having one. So it is in container creating phase. So very soon it will be running as well. And as well as we have one daemon set. Also, we have a couple of deployments. So this is very important. Like, you can say like Prometheus server, Prometheus push gateway, and queue state matrix. So there are three deployment was created. So when we actually run the hem chart, so under the hood, it actually have all these things. So it created deployment, then services, replica set. So all these things, it automatically created. So we can wait for a minute or so until these pods are completely in a running state. So it's fine that we are having the node exporters are running, and I think our Prometheus service is being created as well. All right, so we can see that all the pods are right now running, and we can see this Prometheus server service is basically a cluster IP service. So we can't access this particular service from our external world. So what we're going to do, we're going to expose this service uh, so that we can access it from the internet. So let me do that. So what we will do, we will say kubectl expose this service, and we can say load balancer as the type of this service. It's not a cluster IP or node port, and we can say target port is 9090, because that's the container port for the Prometheus server. And we can give it a name like Prometheus EXT, so that this service can be exposed to the external world. So if we go back and check these get all. So we can see right now we are having these Prometheus external services being created, and there is one external IP that is being created right now. So let's wait for some time, and within a minute or so, we will get one external IP. Now, if you see this load balancer is basically has been created over. So if you just take the load balancer, you can able to see that one load balancer is created for these Kubernetes service. And so this is the load balancer that is being created by these Kubernetes. And for this load balancer, we're just waiting for get the external IP address. And now we got the external IP address. Now, if we go ahead and check the external IP address, we can see the Prometheus will come. So we can say continue to this site because it's a HTTP service. And we can see the Prometheus is coming. It's a time series collection. So voila, we just got this Prometheus action. So over here, we can enable the history, we can enable as use local time, and we can say like node underscore maybe we can say CPU seconds in total, and we can execute. We can see the logs are coming. We can see the graphs. We can see some graphs are coming as well. All right. So we are having all these things. So as well as we can deploy our one pod and we can see how it looks like. So maybe we can say you um, maybe we can check some replica set or pod container info and can execute. We can see we are having one pod is running and we can have this table as well where all these logs are being captured. Right now, you can see these Prometheus node exporter. It's itself is showing this image. Now, um, if we really expose one of our favorite my app over there, let's Control C, and we can we have one created MyDB and we got the IP address. So this is the private IP. We're just going to grab over there and we can go ahead and deploy our favorite my app with this configuration. Let's see, we can create one deployment.yaml. We can say y deployment.yaml and we can use our Learning Light My App version 1.1 where we have provided this MyDB private IP address and we can save and we can deploy this particular um, YAML and we can check uh, our My App service got created right now. It's just, having this container creating the containers. And once the container will be created, we can check whether this application can be accessible from the Kubernetes. And then we can see how Prometheus can see this Kubernetes service. So let's wait for some time. Yes, it's just running right now one pod. And also we got one external IP address. Let's check the external IP address for accessing our favorite My App. We can see our Streamlit application is just coming up. And yes, I think we can see our version ready. We can see our application is ready and we can say hello and we can insert the item. This actually inserted the item into this Cloud SQL database. We can query it and we can see that it's exactly running fine. Now, if we go ahead and check the Prometheus service and we can see our My App uh, container is actually being shown over here. We can see that this container is running and certainly we can see everything is being logged in our system through Prometheus. So that's excellent. We can check that this is our um, pods and we can able to log our new application through our Prometheus web UI. So the Prometheus is excellent for capturing all the matrices, but the problem is with Prometheus that it cannot show very good information about uh, information of graphs. So you can see that there is a spike we can see due to this new pod that we have deployed. But the problem is that it cannot show a good graph. So that is why we will install the Grafana on top of Prometheus so that the matrices that it captures beautifully, it can be shown in the very visual graphical way through Grafana. So that is what we will do in the next lecture. So in this lecture, we saw how we can install the Prometheus on our Kubernetes service. And this Kubernetes service is basically running this Prometheus on the same Kubernetes cluster in the same node pool. But definitely you can have these Prometheus servers installed in a separate node pool on the cluster so that the cluster can have a set of nodes for these dedicated Prometheus capture the metrics of your Kubernetes system. In the next lecture, we will see how we can integrate Grafana on top of Prometheus. And in the subsequent lecture, we'll play around this Prometheus configuration, how we can configure the Prometheus so that we can check different stuff, different matrices, and how we can configure the targets, how we can configure the different things over Prometheus. We can configure all these stuffs. What are the things we can integrate more with Prometheus, and how we can set up these alerts so that we can have these alert manager to send the alerts in different channels. We can integrate different endpoints for the alert manager so that we can push the alerts to Slack or to some ticketing tool. And this is what we will check on subsequent lectures. For now, that's it in this particular video. In the next video, we'll see how we can integrate Grafana. Thank you for watching. See you in the next lecture. Till then, bye. Take care. Be safe.